Well, hello everyone, and welcome to another episode with your girl Audrey Codner from ACG Math Tutoring. How you guys doing? They were trying to fake the funk with my weather. 1 minute they're like, yeah, it's gonna rain, and it didn't. But all I know, it just made it a little more muggy, a little more, my knees are killing me. Let's put it that way. All right, so as promised, especially if you were here with me yesterday, I said I was going to work on the properties of exponents. So let me slide this over and zoom this in so you guys can take a look at the rules. So as you're coming in, go ahead and keep on tapping. So right now, when you look at exponents, the first thing, this whole thing, that 5 raised to the third power, that is called a power, all right? But the power consists of two things. One is the base, and the other is the exponent. Now, the exponent's job is basically to say, hey, base, this is how many times you're going to multiply yourself. So they're saying that for 5 raised to the third power, or 5 cubed, you can say that 5 is going to multiply itself 3 times. So it does not mean 5 times 3, because that's not what's happening here, all right? So this 3, the exponent, is telling you how many times you're going to multiply its base. So then you can just go 5 times 5, which gives me 25, and 25 times 5 gives me 125. Now, there are some properties of exponents that you're probably going to need to kind of keep in mind, all right? So the properties, one of them, which is my favorite one, is when you have a zero exponent. So when you have a zero exponent, anything raised to the zero power is always going to equal 1. 1 is the start of something, okay? So a lot of people will say 0, anything raised to the zero power is 0. No, you do have a start. Think of the Fibonacci numbers, okay? The first number is 1, all right? Now, the other ones is when we really have to commit to memory, okay? So when we commit this to memory, a product is when you have the same base and you're multiplying. Because remember, product means multiplication. But when you're multiplying, you're basically adding the exponents. So let me put this on a separate sheet of paper just so we can get this. So let me unzoom a little bit. So if I said, for instance, I want 2 raised to the second power times 2 raised to the, let's say, fourth power. So 2 to the second power is saying I'm going to multiply 2 to itself 2 times. But 2 to the fourth power is saying I need to multiply that base of 2 to itself 4 times. So instead of you sitting here and trying to figure out what would that be, then you would just add 1, 2, 3, 4, 5, 6. So this will give me 2 to the 6th power. So another way of putting it would be 2 to the second plus the fourth. And the reason why I'm putting it like this is they both have the same base. So that's where this 2 comes from. So then all I have to do is add my exponents. So 2 plus 4 will give me this 2 to the 6th power. And if they ask you what is the actual value, group them. I know that 2 times 2 will give me 4. So then 2 times 2 times 2, this will give me 8. So I have 8 times 8, which will give me 64. 64. Okay, so 2 to the 6th power is equivalent to 64. And the way I do it, I like to group it. Okay, because I know 2 times 2 will give me 4, and 4 times 2 will give me 8. So why not group these first 3 to give me the 8, and then group the last 3 to give me the 8, and then multiply 8 times 8, which gives me 64. Okay. Hey, Robert, how are you? All right. Okay. So product rules, when they have the same base, you're adding the exponents. Now, if I look at quotient rule is when I'm dividing, hence the name quotient, okay? So when I'm dividing, I'm subtracting the exponents. And you always start with the exponent in the numerator minus the exponent in the denominator. So if I want to say x to the 5th divided by x to the 3rd, okay, if I want to say x to the 5th divided by x to the 3rd, shrink that up. This is saying that I have 1, 2, 3, 4, 5 x's in the numerator. Then in the denominator, I have 1, 2, 3 x's in the denominator. So what I can do, anything divided by itself is always equal to 1. So that means these x's can cancel out, these x's can cancel out and leave me 1, and these x's can cancel out and leave me 1. And anything times 1 is always itself. So in this instance, we have 2 x's left, and they're in the numerator. So my answer will this be x squared. Because my exponent is telling me how many times I'm multiplying that base. So if you don't want to write it out in expanded form, you can just remember this. So you have x to the 5th divided by x cubed. So that means you have x to the 5th minus the cube. And 5 minus 3, that will give me my base of x raised to the 2nd power. And they are exactly the same. Okay, they're exactly the same. Okay. All right. Okay. So where do you use this in real world? How'd you get up this morning? Because that's exactly what you're doing. Okay. No, it is an honest question. How'd you get up this morning? Were you awoken by Leanne? How are you? Were you awoken by an alarm? Okay, because it has to deal with the time and has to do the calculations. Okay. How did you know to subtract? Well, let's take a look. So if you're going to divide, you're usually making something smaller, right? So what you're doing is you're getting rid of what they have in common. So there is one set of x's here that's in common. There's another set of x's there that's in common, and another one. So since they basically give me ones, so 1 times 1 times 1, 1 times itself, no matter how many times you do it, is always going to give me 1. So now, knowing that what you're doing is making smaller, that's how you know you're going to be subtracting. When you divide, you're making things smaller. You have to do subtraction with your exponents. But when you multiply, think about it. When you're multiplying, you're making things bigger. So when you're multiplying, you're not multiplying your exponents, you're adding them. So 2 plus 4 that will give you your 6. Okay. All right. We just got started, Nicole. We just got started. It's okay. All right. Thank you for the flowers. Appreciate you. You understand now? Awesome. Supposed to subtract the exponents when you divide. Yes. You're right on target. Good. All right, Brat, you're confused? Okay. So just got in. Sorry, Leanne. It's like back on the study grind. Yes. All right, awesome. Okay. Your brain hurts? Yeah, we just got started. It's called It's Working. All right. So, again, when we're dealing with parts of a power, you have a base and you have an exponent. Okay? The exponent's job is to tell you how many times you got to multiply that base. So since it was 5 to the 3rd power, I'm multiplying the 5 3 times. So anything raised to the 0 power is 1. Okay, no matter what. You can have parentheses or brackets around something and it's raised to the 0 power. Automatically, you don't have to do anything inside the parenthesis. You just make it equal to 1. So we just talked about the product and the quotient rule. Now I'm going to give you examples of these. Okay, I'm just kind of briefly do a little run through. Okay, so even infinity to 0 power. Yep, anything raised to 0 power. 1. All right, so now negative. If you have a negative exponent, you got to do what's called the reciprocal. You got to flip it in order to make it positive, or AKA negate it. Okay, so if, and I should put the other version of it. The other version is if I have it already as a negative in the denominator, by putting it over 1 makes it positive. So anytime you got to move it, you're basically negating it. Okay? Power to a power. Anytime you have an exponent being separated by a parenthesis and then multiplied to another exponent, this is multiplication. Okay? So 5 times n, or mn for short. Okay, so power to product, all you're doing is distributing your exponent to everything inside the parentheses, so they'll have their own exponent of n. And the same thing is happening with the power of a quotient. So I'm going to break this down step by step as I normally do. Okay, let's see if we can get it up to roughly 4,000. There's 281 of us. We should be able to get up to 4 real quick. So Mad Tap. Hey, Janice, how are you? Yes. Hey, Jess, thank you. Okay. Yep. All right, awesome. Good. About me, I'm doing okay. I'm doing okay. I took my butt to the gym, so I'm feeling pretty good. I thought we were going to have a storm, but it just kind of went right by us. So I'm like, okay, cool. I did not feel like dealing with hail and all that fun stuff. Okay, how are you? I am well, thank you. Nice, I know. All right, almost there, almost there. Keep tapping, keep tapping, keep tapping, keep tapping. Thank you so much for the follows. Thank you so much for the likes. I appreciate it. All right, I know, right? Because that hail, they don't play. It does not play. All right, awesome. Okay, so let's get with tons of examples. So first example, we have 5 to the 2nd power times 5 to the 6th power. Okay, not really solving it, but What could it be? Okay. 10K. Our likes target is, I'm thinking like 100K. Why not? We did it before. Let's see. Let's see if we can do it. Okay, that's easy. All right. Yeah, let's do it for 100K. Because I was told today that if I can get 100K, it will really blast it into the FYP. So we'll be able to get more people. And I'm all about that. If that's possible, that would be amazing. Okay? Especially with over 200 people in this should be easy. All right, so what do we have? Pog is saying cinco to the ocho. All right, how about anyone else? Hey, Doris. Okay. Those are 5s, yes. Okay. Challenge accepted, also. Good. So you have like my 625, okay. So it'll be 5 raised to the blank power. Okay, so Robert's saying 5 to the 8th. Okay, Pog said 5 to the 8th in Spanish. Is it Shell saying 5 to the 8th? Okay, Monique is saying 390,625. Okay, Michael, thank you for the gift. Appreciate it. 25 raised to the 8th. Lost, what are we doing? We are basically looking at the properties of exponents. Okay. So you're saying 15,625. All right. Michael's saying 5 to the 8th. All right. You change your picture, Michael? All right. So we are multiplying. When we multiply, we add the exponents. We keep the bases the way they are. So it's not going to be 5 times 5. We're going to keep that base, which is 5. And we're going to add our exponent. So that's 2 plus 6. So that means that gives us 5 to the 8th power. Okay. And if we do want to say 5 to the 8th power, that's basically saying 5 times 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 5. Okay, we're multiplying the 5s 8 times. So if I really wanted to get with that, and of course, I'm not going to sit here and lie to y'all, I did it on a calculator. Yes, I did. Okay, but I'm going to tell you the truth. If you're doing GED or maybe even ACCUPLACER, most of the time, because you can't use a calculator, they're going to just keep it answer as like 5/8. Okay, they're just going to keep it as 5/8. If they're different bases, we cannot do a blessed thing with them. Good question, RB. RB squared. Okay, good question. Yep, different bases does not work. After live, okay. Sure. Okay, this is basically simple. It's just telling you what the power is. If I had 5 to the 3rd power, that means my base is 5 and I am multiplying itself 3 times. That's all we're doing. Okay, just flew in, Big Al. All right, well, welcome. Nice to see you. Yeah. Big power, not 5/8. Right, exactly. 5 to the 8th power. Okay, all right. So let's get with another one. So let's see. Okay, let's try this one. y to the fourth times y to the third times z. Yeah, you're doing the same thing. Even if your exponents are fractions, PNW, even if your exponents are fractions, you're still doing the same thing. If they have the same base, you add them together. So that means you have to do the rules of fractions. So they have to have a common denominator. And then once they get a common denominator, go ahead and combine them. Okay. All right, so let's see what we got here. All right, so Coach Sherry, Coach, how are you? Okay, so we have y to the 7th z. I know it's hard to type it in. I got you. So I get what you're doing. Jess has y to the 7th times z. Okay, you don't have to put the x for the times because some people might read it as y to 7th xz. And you're like, wait, where's the x coming from? But I think I know where you were coming from. So you don't have to put the times, just put the z right next to it. Okay. All right. So we have y to the 7th, same thing, Leanne, which is good. Don't worry about the x for multiplication, just put the z next to it. Because when you don't see a plus or minus in between variables, that means multiplication. Okay. All right, so you have z and y to the 7th. Okay, we can do that. Y to the 12th times z. Remember, you're adding the exponents, not Carol, not multiplying them. Sorry, I had to change things. Where'd it go? Okay, y to 7z. Good user, Pog. I got you. All right. It says 8y to the z. Okay, in 20 minutes. Awesome. We need another that. Okay, not a problem. I got you. All right, so y to the 7 times z. There you go. You don't even have to write the word times. Just put the z right next to it. Okay, so for Yosha, same thing. Okay, ooh, what kind of comments y'all saying? It's so early. Like, it's only 20 minutes, people. Why we gotta be so nasty? All right, there you go, Leanne. Good. All right, nice. Calpatra, Big Al, good. Michael, good. Nicole, good. All right, we got that. Awesome. The mere fact that you knew that I need to combine these two. Okay, they have the same base. So since we're multiplying, we just had to add the exponents. So that's where your y to the 7th comes from. And then z just tags along. And I forgot to box my other ones. Okay. So now, let's see if we can challenge a little bit. So for the next example, we have 7 y to the 5th, 6 y. What would that equal? What would this equal? Okay. So Robert, oh, thank you. Thank you, Janice. So Michael is saying 42y to the 6th. Do I teach systems of linear equations solving by graphing? I can, but not for tonight. I'm just doing exponents. But if you need all of that, I do tutoring. So make sure you reach out. Brenda saying 42y to the 6th. y to the 5th. Paul is saying 42y to the 6th. All right. Just saying 42y to the 6th, 42y to the 5th, 42y to the 6th, 42y to the 5th, 42y to the 6th. Okay, you need it? Okay, all right. Just go ahead and reach out. So 42y to the 6th, Big Al, thank you for your honesty. So Deb is saying 42y to the 6th. Aside is saying 42y to the 6th. Janice is not sure. Thank you for your honesty. Nicole is 42y to the 6th. RB squared is saying 42y to the 5th. Laura saying 42y to the 5th. Conchita saying 42y to the 7th. Ken is saying 42y to the 6th. Well, we got a battle between the y to the 5th and the y to the 6th. So let me see if I can help break the cycle. One thing you guys know, that the coefficients, the 7 and the 6, you can multiply those. So that's what we got our 42. So we are all in agreement with that. But then it came to the y's. You know, if they're doing multiplication, you're going to be adding. But this is what the problem is. A lot of you guys forgot that when you don't see an exponent, it's assumed to be a 1. So this is actually going to be 5 plus 1, which gives me 42y to the 6th power. So if there's not a number in front of the variable, it's a 1. If we don't see an exponent, it's a 1. Okay, not a 0, a 1. Okay, got it? Awesome. Good. Yes, thank you, Jess. Yep, now you know. Now we got it in our brain. Sure about the 1. Okay. All right. Okay. So, one more. Let's see if we can redeem ourselves. So we got -3 x squared y to the 7th. Okay. 5 x y. Okay. Awesome, good. Nice. It's okay, Michael. It's all right. Alright, so Leela is saying -15x cubed y to the 8th. Jess is saying -15x cubed y to the 8th. Okay, yes, we're going to be doing some tapping. Coach is saying -15x cubed y to the 8th. Michael, -15x cubed y to the 8th. Hey, OH, Ohio, -15x cubed y to the 8th. Deb, -15x cubed y to the 8th. I'm starting to see a pattern. Slick log, -15x cubed y to the 8th. Grant, -15x cubed y to the 8th. Can I explain? Just join. Not a problem. Give me a moment. TY is blessed. All right, -15x cubed y to the 8th. Hey, Latrice. Big Al, -15x cubed y to the 8th. Yes. Doggin, Florida. -15y is good. RB squared, -15x cubed y to the 8th. Millicent. Okay, don't understand this one. I will, Laura. I will explain in a second. Good. The others I caught on quick, but this one just threw me off. Not a problem. I got you. And then Conchita said -15x cubed y to the 8th. You can know this stuff backwards and forwards for the higher level stuff. Oh, yeah, baby. Oh, yeah. All right. And one more. We got Crown that's saying 8x cubed y to the 8th. It's before, but you forgot. That's all right. Okay, so here we go. All right, good. Coefficients, we multiply. Okay, the coefficients we multiply. -3 times a +5, that gives me a -15. All right, so we're good with that. Now, remember what we said. If the x and the y right here, we don't see an exponent, we assume they are ones. So, getting the x's together, all we're doing, since we're multiplying, we're going to add the exponents. So 2 plus 1 gives me 3. So that gives me x to the 3rd power, or x cubed. Then I go to my y's. Y to the 7th times y to the 1st. So since they're the same base and you're multiplying, you're adding the exponents. So that gives me y to the 8th. And we can't combine x and y's because those are two different worlds. This is my final answer. Okay. Okay. Feel a little better now? Okay, got a little lost, but you got that part. Yep, all you have to do is just make sure the 3 is the other side of the x. All right, good. All right, awesome. Okay, so you got that one right. Good job, Big Al. So now, left off the y to the 7th. Okay. So that was the product rule, because when we multiply, we add the exponents. Now, if I get to quotient rule, let me see if I can put a lovely little divisor here, just so you can split it. So if I have y to the 6 over y, what would that equal? So what if both x's instead of y? Then you would add the x's together. So Laura, if this was an x, if this was an x instead of a y, then your answer would have been -15x to the 11th power. Okay, you would add the x's at the end. Okay, we're just about to switch up now. Kristen, you're multiplying. -3 times 5. That's where the -15 came from. So you multiply the coefficients, but you add the exponents. All right, so Coach Sherry, we got y to the 5th. We have y to the 5th. With Pog, y to the 5th. Madden's, y to the 5th. Nicole, y to the 5th. Okay, okay. No clue what to do here. I got you, Ken. Give me a moment. Creator, y to the 5th. Good. Confused how you got 5. Okay, I'm going to show you. So y to the 5th. Dang, you thought y to the 7th. Okay. No clue. Good. Thank you for your honesty. You're confused too. Thank you for your honesty. I got you. I think, yep, we are going to subtract. So negative times a positive is negative. We're multiplying. Or are you talking about up here with the -15? Okay, Michael, it has like y to the 5th. XO, hey, welcome back. XO, y to the 5th. Slide, I get it, but this way throw me off. Okay, so we can do it. I'm going to do it two ways. I'm going to show you the extension, and then I'm going to show you what the property is saying. So the extension is, I have 6 y's in the numerator being multiplied. So that's 1, that's 2, that's 3, that's 4, 5, 6. And my denominator has 1 y. So there's one group of y's that can be divided out. because y divided by y will give me 1. Okay? Anything divided by itself is equal to 1. We don't need this 1 because 1 times anything is itself, right? So if I have 1, 2, 3, 4, 5 y's left, and they're in the numerator, so I have y to the 5th as my solution. But this is what the property is saying. When they have the same bases, and remember, if we don't see an exponent, we assume it's a 1. So that means we really have that base of y, and what's happening, we're taking the numerator's exponent, which is 6, and we're subtracting it from the denominator's exponent, which is 1. So we keep that base of y, but 6 minus 1, that'll give me the 5. Okay, see how you get the same answer? Regardless if you did it as the extended form or you just remember the property. Okay. No, we don't count the groups. The group is what's helping us what to eliminate. Okay, good. What if the exponent is only in the denominator? So if the exponent was in the denominator, let me see if I can put another one. So say let me put this in green so we can change it. So say it was y over y to the 6. So that means you have 1 y on top, and you have 6 y's down below. 2, 3, 4, 5, 6. You still have 1 set of y's that we can eliminate, but that gives us a 1. Okay, so that means in the numerator, you're going to have a 1, because we got that from dividing the 2 y's. And then we have 5 of those y's left, but they're in the denominator. Okay, yep. So it'll be 1 over y to the 5th. Well. But here's the funny part, Mandy. You are. You're watching this. I got you sucked in. You could have easily scrolled by, but no. My sensual voice just brought you in. So welcome in, Mandy. Okay, good, Laura. Good. Not a problem. So welcome. I know, it's a spider web. Trust me, almost everyone on this live has probably at one point in time said the same thing. Okay, not a problem. Okay. Yep, it's very much the same thing, but the only thing is your y to the 5th is in the denominator, Big Al. Yep. All right, good. All right, so before I get to the next one, let's get a little mad tap. Like, can we, I know there's 166 of us. I think we can get it to 45. Okay, I think we can get it to 45. Let's see if we can do a nice little mad tap. Had to come in. Oh, no offense. I know. Trust me. When it comes to here, we're just pretty much straight chill. Okay? And it's like, it's supposed to be to help people with, I think of it this way. I'm here to help people to just ease their mind about math. And I know your experience with math was probably really bad, just like everybody's here was. Mine was too. I had a teacher that knew exactly what was going on, but just didn't know how to teach it. And I know a lot of us got caught in that whole, if you are the first one to answer, that means you're the smartest person and you never want to ask questions. So I'm just trying to debunk all that and just say you are smart enough to understand math and to help your kids, so come on. There we go. Yeah. But and my whole thing is it's going to take a little bit of time, but it's okay. Now, here's the thing. Algebra doesn't have to be your thing. Okay? It doesn't. It's not a thing that you're like, ooh, girl, I know algebra. What? Oh, that's so cool. Just have to respect it, because algebra is everything that we do. The way we got up this morning, if you set an alarm to go to point A to point B, just us being on this app, there's math involved in it. The lighting that we have to deal with, the angles, everything that we do, our fashion sense, the prints, the designs, the colors that attract our eyes, that's all math. Every single solitary thing that we do has nothing to do with math. Has everything to do with math. So my thing is, come in, let me break down some concepts for you. Okay, let's ease it out. There's nice soft music in the background. And we're just here to just kind of just learn. Okay? All right, so nothing too crazy, nothing too maddening. All right. All right. Well, thank you so much for the follows. Yes. Oops. I just saw something that says crazy. Having fun learning. We made it. We need to double tap. Okay. Yay. 30. Yeah. Let's get it up to 40. Let's see if we can get 40, and then I can do our next bit. You love learning? Yes. See, and plus you're keeping your brain active too, believe it or not. Want students to teach each other. Trust me, coach, seriously, they want the kids to teach each other, but here's my thing. That's the blind leading the blind. If they don't know what it is in the beginning, how can they teach their colleagues? How can they teach their classmates if no one knows what's going on? And then all of a sudden you're like, well, we were together. We did a group assignment. Yeah, that was great. But did you know what you were doing? No. The whole self-discovery, it's cute, but it wastes so much time. Okay, sometimes I think a cute activity here and there, that's awesome. Have them do the self-discovery. Then you, as a teacher, kind of bring them together. I get it. But when you just have them all right, guys, go ahead. Go on IXL. Go on Khan Academy. Go, especially during the pandemic, go and teach yourself. You guys got it. No. They don't got it. So that's why for the last couple of years, I have been extremely busy during the school year, because a lot of kids missed so much content during the pandemic. And we're still just trying to get over some kind of hump. And then guess what the districts did? Every single solitary district sped up when they officially got back into school. They just tried to pretend that the pandemic didn't happen. Oh no, we're perfectly fine. And then all of a sudden you get all these kids failing left and right. It's not right, guys. It's not right. It is not right. So, sorry. I got stuck. Share how they got the wrong answers. Exactly. Then everyone's confused, and then you have to unconfuse them. You still love math? All right, Laura, good. When I was in school, I had an A in math until I hit 9th grade and started doing algebra. Yep. I know. Once people started putting letters and numbers together, we're like, wait, what? Why? Why are we mixing this? You've been teaching and catching up my kids. Oh, good, Regina. Good. So hopefully you'll be able to grab some other stuff. All right. Yay. We made our goal. Here we go. All right, so the next one. Let's see. I'm actually going to keep it with this. I'll switch it back to my blue so we get it. So, so we have 10, a to the 7th, b to the 9th, over 15, a to the 5th, b. Let me raise that up. Take a guess, okay? If you think you got it, awesome. If you're not sure, question marks, but at least try it, okay? Remember, we don't have to be perfect. Only God's perfect, okay? Don't ease the stress off of yourselves. Okay. Yeah, calculus. Oh, that's not me. Calculus is not me. But if you ever need a tutor for calculus, you can go to my guy, Robert. He's called Robert, the AP math, or the AP guy, AP math guy. Hold on. Let me make sure I'm saying it. Robert, the AP guy, AP math guy. There we go. He's in here somewhere. All right, good. All right, well, thank you, Erica, for the follow, and thank you for the... All right, not a problem. Yeah, we're trying to build up his, because he just started TikTok, like literally, I want to say a couple weeks ago. So we were going to build his thing up so he can start going live. So then you'll actually have a person that's going to be doing more advanced stuff to help you guys. Okay. Blank number. Okay. All right. I will take that, Ohio. So a squared b to the 8th. Okay, not sure, Ken. All right. Oh, Bree. Sorry, I had totally skipped you. How did that happen? All right. So Bree, you have 2/3 a to the 2nd, b to the 8th. All right. So Ken's not sure. Thank you for your honesty. Laura, you're saying 10 ab to 16th over 15 ab to the 6th. We're gonna have to take a look at that. Okay, Janice is not sure. Thank you for your honesty. Oh, wait. Okay, Bree, we're changing things up. Hold on. Okay, no, it's the same thing. Okay. I don't know what function we're doing. All right. All right, so we have -5, a squared, a to the 8th. Not sure. All right, fine. It's perfect. So, oops, I did it wrong. Okay, make some corrections if you have to. Big Hoot says, Big Hoot, 2a to the 2nd, b to the 8th over 3. All right, so Ken's giving it a try and close. 10 to the 15th, a to the 12th, b to the 10th. Okay, ask yourself the question, Ken, are you multiplying or are you dividing? Okay, I'll try. Good. I love that. Give it a try. Is that do know or don't know? Saying 2/3 a squared b to the 8th. Okay. All right. Same thing with from Northwest. Okay. You agree, Vanessa? All right. All right. Awesome. Look at us, Michael. All right. Love that. 5a to the 2nd, b to the 8th. We got a hum by RB squared. Okay. Sina is saying 2a squared, b to the 8th over 3. Yes, thank you. It's like, I keep getting 10. Okay. Yep, halfway there, Michael. I see it. It's awesome. All right. Okay, so let's take a look. First off, let's think of it not as one big problem. Let's think of it as small chunks. So since we have our fraction bar, that means we're dividing. But if I try to divide 10 over 15, I'm going to get a decimal. So instead of dividing, let's see if we can simplify our whole numbers. So what does 10 and 15 have in common? What does 10 and 15 have in common? Good, EXO. Good, Janice. We got 5s. Good. So if, nice, Big Al. Good. There we go. Ohio. Yes. Dano. Good. GCF is 5. Good. Pog. Roxy. Oh, how you feeling, babes? Okay, 5s. Dolce, where have you been? Haven't seen you in a minute. Okay. All right, good. Ken, good. Michelle, there you go. Welcome in. 5, yes. So if I divide this 10 by 5, and I divide this 15 by 5, 10 divided by 5, that will give me 2. And 15 divided by 5, that will give me 3. Okay, hanging in there? Okay, good. All right. So that takes care of the 10/15ths because we reduced it to 2/3. Now, let me slide over and deal with the A's. We have a to the 7th over a to the 5th. Anytime you see this fraction bar, that means we're doing division. When we divide, we subtract the exponents. So this is going to be a to the 7 minus 5. And what we get left over is 2. And where are those 2 going to be? They're going to be in the numerator. Because if I have 7 A's and I did the expansion form of 7 A's in the numerator and did the expansion form of 5 B's in the denominator, 5 A's in the denominator, all the A's in the denominator will cancel out and leave me with 2 A's in the numerator. So that's why in the numerator, we're going to put our A squared. Okay. Then sliding over to the B's. Okay, so now we're basically looking at the B's now. There's 9 B's in the numerator. There's 1 B in the denominator. So if I want to, I can do the extended form of 9 B's and the 1 B. So there's only 1 set of B that's going to cancel out. And there'll be 8 B's left in the numerator. Okay, so we have 2 times a squared b to the 8th over 3. Okay. Questions? Okay, thank you, Body Sculpting. Okay, no questions? Where did I get the b to the 8th? Sure. So I have b to the 9th minus, remember, if you don't see an exponent, it's assumed to be a 1. So 9 minus 1 will give us 8. Got it half right. Yes, you did. You just didn't know what to do with the coefficients. But does it make sense now? Okay, you're welcome. Yep, when you're dividing, you subtract the exponents. When you're multiplying, you add the exponents. Am I a math teacher? Yes. I'm no longer in the classroom. I decided to start my own tutoring business. Just completed year 5. So I'm going into year 6. All right. So if you need assistance, just go ahead and message me. You just caught a headache? I know, the synapses are just firing. Everything's just firing away. You're stimulating your brain. Good. Okay. What happens? What you've adding and subtracting. What happens to the exponents then? When you're adding and subtracting, you're not doing anything with the exponents. You're just using them as matching. Okay, we were kind of working on that yesterday. Let me see if I can find it. Oh, let's say, for example, right here. So we have 30x squared plus x squared. So remember, it's assumed that there's a 1 in front of that x. So those are considered like terms. So all you have to do is add the 30 and the 1. That's where the 31x squared came from. So the exponents don't do anything when you're adding or subtracting. You're just playing the matching game so you can figure out which ones are your like terms. Okay. Okay, good. All right. So only when you're multiplying and you're dividing, or when you have a power raised to a power, that's when you're going to start having fun with the exponents. I know someone's like, fun, she says. I know. See, that's what I'm saying. You're going to need, and I know people are just, you keep fighting me, guys. I know you keep fighting me. But trust me, I fight back and I fight dirty. So you need to put these on index cards. If you don't have index cards, just get some paper, right? Get some paper if you have any copy paper. And just get some paper, put them into like little folds. Maybe even like put it into smaller folds. And what you do is you write the product rule on one side. And just say product rule, and then have your a to the m times a to the n, and you're like, add exponents, and then you write your answer. And you go through it. So the next one will be quotient rule. Write the quotient rule, and on the back, subtract the exponents, and then write an answer. Okay? By having flashcards, like don't buy flashcards. This is the thing that everyone keeps trying to do. You can't do shortcuts on memorization. You got to old school it. Okay? By you writing it out on a piece of paper and saying what it is, you're helping that part of the brain to fire off and say, "Oh, you want me to remember this? Okay, so you don't want this in short-term memory. You want it in long-term memory. Oh, okay. Oh, so you're writing it down a couple of times. All right, got you. You know, so you have to train your brain. Okay, you have to train your brain with that. So let me see. Those equations are long. Yep, that's what happens. Could be written. Okay, so your answer goes in the numerator. Yes, because that's where your leftover A's and leftover B's are found. So if I did the extended version, I had 7 A's up here. I have 5 A's down here. So if I cancel out, all my 5 A's in the denominator are gone. And what's left is 2 A's that are found in the numerator. Okay? So if you ever subtract and you notice your answer turns out to be negative, that means your value should be down in the denominator or vice versa. Alright, most definitely. Thanks. Yep, not a problem. Math smart. You will. You will. You will. Alright, let's try one more with the division. Let's try one more with the division. I think. Yes, cat. Yes. I know. This is how you eat, cat. This is how you eat. I know. It's all kinds of crazy. Actually, let's jump in. Let's do this. I have one cat outside, and this one's like, I want to go outside. I tried to give you your opportunity to go outside before I got on live. You didn't seize the opportunity. All right. So for this one, okay, this is one of, I can't even say I own them. All right, good. You're doing intermediate algebra in college and you feel dumb. Don't say you feel dumb. You're not dumb. It's a fast course, and no one told you that it was going to be a fast course, and you haven't seen it since you were a fetus. Okay, so shake it. If you need assistance, reach out. Okay, I have some other people that I'm helping with intermediate algebra. I got you. Okay. All right. Yep, you're gonna be fine. Just gonna walk it through. Okay. Practice makes perfect. Exactly. Just All right. Here we go. So I don't know who you calling baby, because that's not me. All right. So we have x to the second power, and it's being raised to the 8th power. Now, this is what's called the product of a power. When you see an exponent being separated by a parenthesis, and then it's also being addressed with another exponent, you are basically multiplying your exponents. Oops. Okay, you are basically multiplying your exponents. So when you see an exponent, parenthesis, exponent, you multiply them. And I'm going to show you why. So this is saying I need to write x squared 8 times. So this is the extended version. So basically I'm going to have x squared, that's 1, 2, 3, 4, 5. Let me shift it over. 6, whoops, that's ugly too. 7, 8. All right. Let's see if I can shrink that down a little bit. Yeah, monotonous, right? Because it's telling me everything that I have inside that parenthesis, I'm multiplying. They're saying that x squared is going to be my base, and I'm multiplying my base to itself 8 times. So if you think of it this way, yeah, that was an 8. I'm sorry. So if you think of it this way, since we're multiplying, what do we do with the exponents? Okay. Since we're multiplying, what do we do with the exponent? Ooh. What were you trying to say, Coach? TikTok blocking it. Okay. Yes, we're going to follow the rule, which we're going to. There you go. All right. So is it Shason? Okay. So Shason, we got adding. We're going to add. Hala, we're going to add. We're not going to multiply the exponents. We're going to add the exponents. We're multiplying the bases, but we're going to add the exponents. All right. Right. Okay. So we have our 2, 4, 6, 8, 10, 12, 14, 16. Okay. So this gives us x to the 16. If you notice, we got the same answer when we just, multiplied our exponents. Okay? All right, so we're just breaking on down. Exactly, Jason. Exactly. So when you're dividing, you subtract the exponents. When you multiplying, you're adding the exponents. But when you have a exponent being raised by an exponent, you're multiplying them. Okay, you're multiplying them. Yes, I am breaking it down. Okay, no problem. All right, so, okay, why do I add them? Well, because when you're multiplying, and I kind of broke it down a little earlier, so when you're basically having a exponent be raised to an exponent, you're breaking it down. So I could do the extension. I can say for this one, let's say 5 squared. 5 squared is 5 times 5. So that means I have 5 times 5. 5 to the 6, that means I have 5 of the 6s. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6. Woo, it's supposed to be a 5. I was thinking 6 and I wrote 6. So instead of dealing with this long extended version of it, you know that you're going to have 1, 2, 3, 4, 5, 6, 7, 8 5s to deal with. That's where the 5 to the 8th came from. So it's easy for you to say with the rule, when you multiply, you add the exponents. When you divide, you subtract the exponents. Okay? You're trying to make life relatively easy for yourselves. Okay? Oops. Keep stopping all my stuff. Okay. Okay, I'm from Maryland. Thank you. Rational equations. Yes, I actually did. So if anything, you can go here because I put all my replays there. And this is the title of it. I can't say the word because then I'll get dinged or get a violation from TikTok. So all of my lives are recorded and placed there. Okay. All right. Not a problem. All right. So let's tap it. Let's get to 80. Can we get into 80? Let's tap it to 80. There's 107 of us, like quick taps. Good. All right. Let's get it up to 80, and then I can get to the next one. There we go. All right. Everyone's got it? Awesome. And I'll try to write a little bit bigger. All right, thank you. Well, thanks. All right, yeah, we're doing pretty awesome. Thank you for the tapping, guys. I appreciate this. Because we are getting new people. So when you're working the exponents inside parentheses, you add, but out, you multiply. If they have the same base slick, yes. Okay, if they have the same base, yes. Yep, that's the goal, Roxy. Okay, ask her if she can show you how to complete the equation. Okay. Is that a 4? Yes, it is. It is a 4, dead. Yes, yes. Okay. We do outside the parenthesis. Yes, I know. They are lovely, but they have their moments. They're cats. Like they're just gonna have like those instinctive, like the 1 minute they're licking each other's heads, the next minute they're slapping each other silly. I don't understand it. They don't understand my world. I don't understand their world. They just like to get fed and pet once in a while. All right. So one question. When you said outside the parenthesis, so if you have a power being basically raised by a power, you multiply the exponents. No, they're not hungry. I fed them. Trust me. They will. Especially this tuxedo one will eat you out of house and home if you could. Exactly, on their time. And this is around the time that they're like, let's cuddle. Let's go outside. Human, caress my head. Human, fetch a treat for waste. Okay, so you're thinking 64 x to the 9th, y to the 3rd, z to the 3rd. It's starting to rain? Okay. Alright. Well, she's got her own little hut. Again, they're spoiled rotten. How can you, like, 1 minute be a homeless cat and next thing you know, have nose poked up at things? Okay. What sorcery is this? This is math with exponents. Magical things. Alright. So, now, everything inside this parenthesis is being raised to the 3rd power. Okay? So, Jason, you were right. So we're going to have our 4 being raised to the 3rd power. We're going to have x to the 3rd be raised to the 3rd power. We're going to have the y being raised to the 3rd power. And we're going to have the z being raised to the 3rd power. Okay? So, put parentheses around that. So 4 to the 3rd power. It is not 12. Okay? This is saying that we have a base of 4 and we're going to multiply it to itself 3 times. So that's 4 times 4, which gives me 16, times 4 gives me the 64. Okay? Because 16 times 4, that gives me 64. Okay? That's okay, Kathy. Well, you're going to come in and let's see if we can just do some math in a calm manner. We don't have to worry about exams. We don't have to worry about passing anything. Let's just look at math in its natural form. Okay? We're going to be all right. So now we have x to the 3rd raised to the 3rd. When I see an exponent, a parenthesis, and an exponent, that means I'm going to multiply the exponents. So that will give me x raised to the 9th. Because 3 times 3 gives me 9. Okay. Good. So now we go to the y. Original y, it looks like we don't have an exponent, but it's assumed that there is a 1 there. Same for the z. So here we have 1 times 3. So that will give me y to the 3rd. When we go to the z, we have z 1 times 3. That gives me z to the 3rd. So basically, you're almost like you're doing the distributive property. Let me zoom out a little bit. So you're doing like the distributive property with your exponent. You're raising everything to the third power. Okay, including the 4. All right, here we go. All right, good. Well, thank you, Excel. Yep, we'll be there before you know it. All right. Questions on that one? I'm going to do another one similar to that. Okay. So let's try this one. Okay, 2 times x to the 8th, y to the 4th, all raised to the third power. Okay, so Ohio is saying 8x to the 24th. Okay, y to the 12th. And Coach is saying 8x to the 24th, y to the 12th. Debbie's saying 8x to the 24th, y to the 12th. I'm starting to see a trend. Okay, Miss Honeywell, thank you for the follow. All right. Zena saying 8x to the 24th, y to the 12th. Deb, 8x to the 24th, y to the 12th. Janice, 8x to the 24th, y to the 12th. Jordan, 8x. We're going to take a look at that. So Michael, 8x to the 24th, y to the 12th. Okay. See one more. All right, so Ab is saying 8x raised to the 512, y to the 64. All right, yeah, we're almost there. All right, so let's take a look. Okay, we were doing well, then we made a curve. So the 2 is being raised to the third power. The x to the 8th is also being raised to the third power. And the y to the 4th, that's being raised to the third power. Okay, so when you break it down into small chunks, it's not as intimidating. So now we need to take a look at my 2 cubed. So this is saying not 2 times 3, but this is saying 2 times 2 times 2. 2 times 2 gives me 4, and 4 times 2 gives me 8. So that's where the 8 came from. So here we have x to the 8th raised to the third power. So since we have a power being raised to a power, there's a parenthesis involved. That means we're going to multiply my exponents. So you got x to the 24th. Same thing is happening with the y's, but this time we're doing 4 times 13, and that will give me y to the 12. So we can't combine these two because they're not the same base, so that means this is my answer. Now here's a quick tip for if you're taking the GED, ACCUPLACER, ASVAB, even just a general math class that deals with exponents. If it is a multiple choice question, do what you know. If you can remember that x to the 8th to the 3rd power means multiplying, that means your x should have an exponent of 24. Take a look at your answer choices and see where is there x to the 24. If 2 answers has x to the 24th, okay, you know you eliminated a couple of them. Then take a look at your leading coefficient. If both of them have an 8, all right, then you definitely have to take a look at your y's. So sometimes you don't have to do all the work, especially these type of exams. Most of the standardized exams, they're not going to look at the work that you're going to do. They don't care. They just care, did you push A, B, C, or D? Did you bubble it? Did you click it? Did you move on? So like if you can do the 8 times the 3 to get you 24 and the 4 times the 3 to give you 12, then take a look at your answer choices to see which one has the x to the 24th, y to the 12th. And if only one of them has it, that's your answer. Click it, bubble it, move on. Okay? Because when you take this test, remember these exams are timed, as well as the GED and the ASVAB, you cannot use a calculator for. So a lot of these facts that we're doing, if you're used to practicing with the calculator, you're not going to do well on the test. I'm just going to let you know and be very blunt and honest. Okay, so you're going to have to learn to process these things without a calculator. Okay, so it just takes practice. It takes practice. It's not 2 times 3. Nope. It's the 2 being multiplied by itself 3 times. Okay. All right. Oh, yay. We made it. Just looked at it. All right. Yes. A couple more questions? Of course. Of course. Well, you thought like once we get 1,000, we stop? No. I stop when this paper is filled up. And if I have to take it to the side, I will. Because exponents is huge. Especially the GED, those are your 3-point questions. The exponents are, especially these type of things, they're your 3-point questions. We want to make sure you get those. Okay, those that are taking the TEAS test, there are high scoring questions as well. And they will always give you 6 as one of the options. Okay, they'll always give you that. Let's try this one. Okay, this one I might want to walk you through. You're like, whoa. Okay. Copy it down, and I'm going to walk you through it. Okay. Yeah. Okay, we're going to take it step by step. Okay, we're going to take it step by step. All right, let's take a look. If you think you got it, go ahead and do it. If you're not sure, come rock with me. So first thing, this is being raised by a negative exponent. So just like what we did with the other ones, we're going to give, I'm going to put it down here because we don't have that much room. So I'm going to take the 6 and I'm going to raise that to the negative second power. I'm going to take my x to the negative 6 and raise that to the negative second power. I'm going to take my y to the negative 7th and raise that to the negative second power. And then I'm going to take my z to the 0 power and raise that to the negative second power. So, as I mentioned before, okay, let's not look at the whole entire thing. Let's cover up this first part. So we have 6 raised to the negative second power. We can't have a negative exponent. So if you recall, oops, starting to stick to papers. When I recall, when we were talking about negative exponents, oops, okay, when we have a negative exponent, we gotta flip it. If it's a whole number, we gotta flip it to the denominator, okay, making it a fraction. But if the negative exponent is in the denominator, we're making it into a whole expression. So in this case, when we have zoom in a little bit. Hold on. There's all kinds of stuff going on here. I do one thing and all kinds of hell breaks loose. Okay? So we have 6 to the negative second power. So in order for me to have this as a positive exponent, right now it's kind of doing this. It's kind of over 1. Anytime you see a whole number, it can easily turn into a fraction by putting it over 1. It does not change the value of the number, the original number. So we're actually going to flip this so we can negate or make this negative exponent into a positive exponent. So this is what's happening. The 1 is going to go in the numerator. And now this is going to be 6 raised to the second power. Okay. All right. Yes. So SWAD, yes. Okay. Hey, Latoya, how are you? All right. So it's not going to be a negative 36. It's good that you recognize the 36. But since my exponent is negative, I have to flip it in order to make it positive. Okay. So in this case, this will give me 1 over 36. Okay. So with that being done, now I'm moving over to X. Let's let this piece of paper before doing the power rule. You could flip it before doing the power rule, but take a look at what's happening here. Here we have X being raised to negative 6 and raise that to negative 2. So we're going to multiply the exponents. What's a negative times a negative? Okay, good, positive, good, positive. Yes, positive, good, positive, awesome. Cookie, hey Cookie, I don't think I said hi to you earlier, sorry. Hello. Yes, so it's going to be positive. So in this case, this is going to give me X to the positive 6 times 2, which gives me 12. So that's going to be in the numerator. Now, let's go with the Y's. Looks like the same situation with the y's. But this time we have -7 times -2. What are my y's? Y raised to the what? Yeah, stardust. Good. Good. That's it, Janice, Deb, Michael, Ab. Yes. That gives us 14. Is it Abdel? Okay, Vanessa, good. Coach, good. Okay. So again, we have y to the 4th. Now that it's a positive exponent, it's going to stay in the numerator with the 1 and the x to the 12th. So now, this last one, what do I get with this last one? What do I get with the z? Oh, well, congratulations. Man, this is late for graduation. Woo. Okay. Careful, coach. Okay. Michael, you got the 1. No problem. Okay. So, we got the exponent of 0. Because take a look. If we're going to multiply, just like how we multiplied the y, -7 times -2, and negative times a negative gives me a positive, and 7 times 2 gives me 14. Same thing's happening here with the z's. 0 times -2, that gives me z to the 0 power. And anything raised to the 0 power is 1. So this is actually going to give me an answer of 1. So now all we have to do is clean all this stuff up. So we have our 1 over 36. So my 36 is in my denominator. In the numerator, since it's positive, will give me x to the 12th. Same thing with my y's, that's y to the 14th. And then all those are being multiplied. So I don't have to put the 1. I can, but it's understood since we have our x squared and our x to the 12th and y to the 14th. If you want to put the 1 there, that's not going to hurt anything. Okay, but if you don't put the 1 there, it's understood to be there. So since we don't have any like terms, this is my answer. And I will pause for questions. Okay. Yep, so since that was a negative exponent with the 6, we had to flip it. We had to flip it to negate it to make that exponent positive. So the act of flipping is making your exponent be positive. Okay, it's almost like Pac-Man. As soon as he eats the power pill or whatever it is, then he transforms and now he can like overcome. All right, same thing is happening here. So then he changes direction. So instead of being chased, now he's able to go after. I know that was really deep. Like I should put that on a t-shirt. Life is like Pac-Man. Yes, you can do multiple flipping. Yes, you can. What happened to the z? Well, anytime you have an exponent of 0, that equals 1. So since we did 0 times -2, that gives me 0. So anything with the 0 power automatically equals 1. Because since the 6 had a negative exponent, But after we multiplied the x and the y, we got positive exponents. So when they got positive, we don't have to drop them down because they're positive. Whereas the 6, we had to flip it in order for it to be positive. So that's why it ended up in the denominator. So we don't add z to the first. The z is gone because z is 1. Anything raised to the 0 power is equal to 1. So z is now transformed. Z was the caterpillar, now it's a butterfly. Okay, so z goes away, it becomes 1, yes. Okay. Yep. Yes, I know, and it's just like kind of getting that property. So repeat the flipping, okay? Anytime you have a negative exponent, you always have to flip it because you can't leave a negative number in your final answer. It's just a math thing, okay? They always want to keep it positive. So in order for me to negate or to change this negative exponent to a positive, I have to flip it. So that means, since that's not originally a fraction, we had to make this expression into a fraction and then flip it. So that's where the 1 is coming from up top. And then you have 6 raised to the positive 2. So 6 squared, that's 6 times 6. That's where the 36 came from. And that's why it goes in the denominator. Yes, it'll be wrong, Big Al. Yeah. Because it's not z to the first. It's 0. Z is gone. Okay. You need help with college algebra? All right, I do tutoring, so make sure you message me. Okay? Message me either tonight or tomorrow. Okay, so I can help you out as soon as possible. Hey, Val. To do your homework? Yes, Val, this is your sign to do your homework. Okay. So what's the difference between y with the negative numbers than the first one with the negative number? Because they're no longer negative. Because once we multiplied the negative 6 with the negative 2, a negative times a negative gives me positive. So they're not negative anymore. Whereas here, I didn't have anything to multiply it to other than the 1. So which still gives me a negative 2 as an exponent. So it didn't transform from a negative to a positive. So in order for me to change it from a negative to a positive, I had to flip it. Okay. All right. Okay. What about if the negative exponent is in the denominator? Then you flip it to the numerator. If it's in the denominator, then you flip it to the numerator to make it positive. Yep, you're always flipping in order to make your negative exponent positive. All right. Okay, let's see if we can do. Let's give this one a try. It's like, I'm sitting here like, why is my paper like, my book is almost at the edge of the desk? Like, what is going on? I was like, oh, all I have to do is just move my camera down. Scary thought, man. Scary thoughts. All right, so let's try this. So we have 5x to the negative 8 over 2y to the 4th raised to the negative 5th. Okay, take your time with this. Take your time with this one. Oops. Sorry, I keep moving my camera. There we go. Could flip all day. What do you mean, nope? At least give it a try. Let's give it a try. If you get it wrong, we'll make the adjustment. If you get it right, we'll celebrate it. There you go. That's as simple as that. All right. Dion's saying 2y to the first power. Okay. Okay. All right, not a problem. No problem. No sad faces. Go ahead. Take the time. Okay. You distribute to everything inside the parenthesis, correct? Yep, distribute to everything inside the parenthesis. Okay, keep going, EXO. Keep going. Okay, mental math's not mathing. Okay. You're stuck like Chuck? Okay. All right. Nope. Okay. Okay. Hello, Mickey. All right, Deb saying 32y to the 20th over 3,125x to the 4th. Interesting. See what I mean? All right. Okay. Am I giving enough time for people? You love it here. All right. It's that -5. Okay. Need help? Okay. You too? Okay. You got x to the 40th, y to the 20th in numerator, but now have to do the constants. Okay. This is a challenge. Okay. Good. So, Yeah, notebook. Can't keep straight in my head. Yes, definitely Deb. Now, just like we've done before, we're distributing this -5 to everything inside the parenthesis. Okay? There's a reason why I'm doing that, and I'm going to explain in a moment. So we have the 5 is being raised to the -5th power. We're having the x minus 8 being raised to the -5th power, so that's our numerator. Then our denominator is 2 being raised to the -5th power, and y to the 4th being raised to the -5th power. So, looking at my x's, I have -8 and -5. So a negative times a negative will give me a positive. So that would be my x to the 40th. And that's going to stay in the numerator, because a negative times a negative gives me a positive, and since it has a positive exponent, it can stay right where it is. But the 5 has a negative exponent, the 2 has a negative exponent, and the y minus 4 has a negative exponent. So where they originally are, we need to flip them. So the 5 raised to the -5th power was in the numerator. Now we're going to put it in the denominator. Okay, with a positive exponent. That 2 to the -5th, since it was in the denominator, now that's going to go into the numerator to make our exponent positive. And then down here, we have 4 times -5, so that will give me a -20. So it's not going to be down here in the denominator, it's going to be up here. And instead of a -20, it's a positive 20. Every time you have a negative answer, you need to flip it to make it into a positive exponent. Yes. Okay? So the reason why I could, from the very beginning, I could negate or flip everything since it's being raised to a negative exponent. I could have moved everything down, so that will be like a 2 and all this other stuff. I can do that. Or if you want to make them individual like this, so you can see it, you can do that as well. Okay, so the x is staying right where it is because it gave me a positive exponent. The y had to move because it was giving me a positive exponent. And then the 5 dropped down to the bottom, so it has a positive 5. And the 2 moved on to the top because it's a positive 2. Okay. But in order for you to do the subtraction look whole, they have to have the same base. And none of them has the same base. Oh, we got a different cookie? Yes. Okay. Yep, I do. Okay, this is where you can go to get the replays. Alright, that's where we can go to get the replays. Alright. Raised to a negative power goes into the denominator. Or the numerator. Robert, if it's down the denominator, like this one was. So you always got to do the movement opposite. So for the numerator, okay, So now, finishing it out, you have your 2 to the 5th power. So 2 to the 5th power, that gives me 32. Then we have our x to the 40th, y to the 20th, over my 5 to the 5th power. That's my oops. So this will be raised to the 3,125. Okay, thank you, Michael. How did I get 32? 2 to the 5th power. So that's 2 times 2 times 2 times 2 times 2. 2 times 2 gives me 4. 4 times 4 gives me 16. 16 times 2 gives me 32. Another way to the same answer? Sure. So if I go back to my original, which is this, since it has a negative exponent, that means in order for me to change this to a positive 5, I gotta flip everything inside of the parenthesis. So that means my 2 and the y to the 4th is going to be the numerator. And my 5, my x to the negative 8 is going to be in the denominator. The only thing that changes is the negation of the 5. Okay, we have to flip everything inside the parenthesis, but we're making this exponent a positive. So now we're going to raise everything to the 5th power. So that means the 2 is being raised to the 5th power. The y to the 4th is being raised to the 5th power. The 5 is being raised to the 5th power. And this x minus 8, that's being raised to the 5th power. Okay. So since down here we got negative 8 times 5, that gives me a negative 40. So now all I have to do is just put that x up to the numerator. So then I have my 2 to the 5th, which is 32. Y to the 4th raised to the 5th, that gives me y to the 2nd. And then since it's going to be a positive 8, because we're flipping it up, it'll be a positive 40. We have our x to the 40th. I don't know why I have a parenthesis there, but it's not going to kill us. And then what's left over is my 5 to the 5th power, which gives me 3,125. Okay. Oh, thank you. Supposed to be a 0 there. All right. Yeah, it's supposed to be the 20th. Feel the GED? Yes, it will. Okay. Yeah, it's supposed to be y to the 20th. I'm sorry. Yes. Okay. Yep. So it's really kind of getting that rule. If I can stop being stuck to papers. Yeah, it's really trying to get these rules down. Okay, really trying to get these rules down. And also through practice. Okay, and also through practice. Alrighty. Okay. Well, my bed is calling for me. The cat is being very patient right now. But before I skedaddle, as you can see, we don't have that many pages left in this notebook. So this notebook will actually probably be finished by possibly this week. And if you're wondering, all right, if you like how the notes are somewhat designed, I actually designed this notebook, especially for people that are brand spanking new. What I do is I basically just got sick and tired of my tutoring students coming to me with packets of papers. And then when I ask them, what does this packet of paper mean? They have no idea. So I designed a math notebook, and especially for us advanced or older students, you know, from 7th grade all the way up to adults. No one really designed stuff for us. Everything is always designed for elementary. So in our case, we have a part where we can put formulas. We have a part where we can put rules or steps. Then you have some sections over here, as well as some space over here in the grid. And if you're a teacher or a homeschool teacher and you actually like, hey, what's the kid's attitude, you know, before the lesson? You know, have them self-reflect. So how do they feel before the lesson? How do they feel during the lesson? How they feel after the lesson? So like, especially when you have observations and the observer always asks, how do you know that your kids are learning? Then you can tell them, well, did you walk around and see their mood trackers? So make them get up and walk around and see that. So I take pieces from worksheets. Sometimes I'll take stuff from my old notes from back in the day. And then I just try to compile everything into a book. So in addition, there's 3 different covers with the notebook. And in addition to all this, we have some resources in the very back. So I have a factor chart from 1 to 200. So if you need help breaking down radicals, breaking down factoring, so you can figure out what numbers you should use. You also have the rules of integers, adding, subtracting, multiplying, and dividing, as well as the most used words for terminology operation. Then we have the order of operations. Hey, look what's here. Properties of exponents. We just worked on that. Then we have the linear and the quadratic equations. And then like some properties of transformation with geometry, as well as the properties of quadrilaterals. And I know for me, I always forget those. Volume, surface area, the arc length, the area of the sector, area and perimeter, and also circumference for the circle. Speaking of circle, we got the unit circle, and then we also have some forms of trig. Okay, and then I try to give like some kind of brain break, just a little activity to help you get you back on track. All right. So if you actually say, you know what, Audrey, I love your notes and I want your notes. Well, I'm also selling these called Audrey's Notes. So Audrey's Notes is a collection of all my notes. And the one thing that I really like about this, that I just kind of did, each of the section has a QR code. So if you scan the QR code, it will take you directly to the live that's coordinated with these notes. So all you have to do is just scan the QR code and then have fun. That's it, right? So all of them, and it's like all the multiple pages. So if anything, you can check out my profile to kind of help you get to where you can purchase those. I can't say the name because I'll get dinged, and I don't feel like being dinged tonight. All right. Can we do one more? Okay. Just got here late. I am sorry because I need to go to bed. I'm just like, so I'm going to try to upload the video as fast as I possibly can so you can get access to that. Okay. And again, just go to this. Can't even say it anymore. Just go here to get the replays. Okay. So just go there and get the replays. Those are called exponents. It's the properties of exponents. So we did them with numbers as well as variables. Okay, so tomorrow going live. What is tomorrow? Tomorrow is Monday. So I will be actually going live at 1 p.m. and I'm going to try to go live again at 10 p.m. I actually did pick up a couple of people, but I will try to come on again at 10 p.m. But I'm definitely coming on at 1 p.m. Okay. Okay. All right. Awesome. Well, thank you, Miss Honeywell. I appreciate that. Okay. All right. So the topic, I'm not sure yet. Okay, can I do graphing inequalities? I can. Is it graphing linear inequalities or graphing inequalities on a number line? Bree. Linear? Okay. All right, so this is what I will do. So we got graphing inequalities and simplifying radicals. Okay. And the number line? So if it's linear, that's using an axis. So do you mean just on the number line or on the axis, the XY axis? Pick one of the two because it's two different concepts. Axes? Okay. All right. Thank you. All right. All right, so what I'll do is I'll do inequalities in the morning, and then I will do radicals, simplifying radicals in the evening. That seems like a fair compromise. So at 1 p.m., we're going to do linear inequalities. At 10 p.m., we're going to simplify radicals. All right, that sounds fair. We can do that. Yep, that's with the shading and everything. Yep, I'll do those tomorrow. Yes, you need all of that. Okay, all right. Okay, and shading, thank you, no problem. Okay, cool, thanks, not a problem. All right, so yes, if anything, here's also, if you get a chance, I think some of you are new. There's a couple people that I would love for you guys to follow. So we got a Blessed RN if you're thinking about doing nursing and you need help with dosage calculations. Impact Math, I think a lot of you guys know Miss Taylor. She does the T's, the ASVAB, and the GED, but she comes on at 2 p.m. So like after me tomorrow, you can shoot over to her and get some more practice with like ASVAB or GED. I know her PMs are usually when she has her subscription ones. Those are the ones you have to pay for, but her morning ones are free. And if you're looking for a chemistry tutor, Professor TK is a great person to follow. If you're wanting to find out how to add, subtract, multiply, divide using the abacus, not just 1 digit, but 2 and 3 digits, go ahead and follow my friend Learning with Lynette. She's pretty fun with that. If you have any younger kiddos in pre-K or kindergarten, and you're thinking about homeschooling and you need help with curriculum, also follow my friend Nancy, is the online elementary tutor. And she also does elementary reading and math, as well as my friend Robert, the AP math guy. Anything with doing statistics, AP statistics, Cal A, B, B, C, even the AP pre-calculus, go to Robert. Not me, Robert. And then if you have someone in elementary or middle school that needs help with math, I also have my other friend, Bridget Hauser. She is doing reading, read, math, grow. So she does reading for K through 8 and math through K through 5. So these are really good people. The last two, I'm trying to get them to go live. They need followers. So if we can get them with their followers, and like Robert's videos are doing extremely well, I think, for the first time being put up there, like they're really starting to take off, which is awesome. So how do I get my notes? Well, if you go to my bio, or if you go not to my bio, to my profile, go to my profile, click on the links, this one, okay? And that will take you to this, and you can see that, okay? And you'll be able to purchase them. Okay, so I do my private tutoring. I have these math notebooks. I'm currently working on some new ones to add to my collection. And I also do self-paced courses. So I have one that you just do the course, have fun with it. You can ask me a question here and there, versus the one that you actually get 30 minutes, like 4 30-minute tutoring sessions. And a lot of that got placed in there because of our fundraiser, help saving my house, and I'll keep to my word. So for those that needed more assistance, they can get the course and go through it themselves, but then they can say, hey, Audrey, I got a question, and we'll be able to meet up because of the extra funds that we got from the fundraiser. So thank you. All right. Yes. Thank you, Jess. Because I can't say it. Thank you, guys. All this tapping. I know you guys have carpal tunnel. Like, this is crazy. I know it's hard. But I think having more and pushing out to the FYP, all the people that came in and they're just like, why is there math on my FYP? And I realized that they needed to come here. So it's all because of all the tapping that you guys did. So I greatly, greatly appreciate it. Just the more the merrier. More to help more people as best we can. So if anyone needs assistance, Algebra 2, intermediate algebra, you're currently taking a college algebra class and you need assistance, stop struggling in silence, okay? Get a tutor, which is me. All right, so I would definitely work with you financially, but here's my thing. You have to get it done. If you want to pass this class, don't do what some of the schools are doing. Yeah, let the kids teach themselves, and they don't know what they're doing. So it doesn't make sense. All right? Okay, so I am done. I am burnt out. I am crispy right now. So hopefully everyone is doing okay. Hopefully they're feeling a little empowered, feeling a little bit confident. That would be amazing. And if you want to purchase the notes, again, look at Jess's comment. You can go there, or you can go here, which is in my profile. And it will take you straight to the comments, because I also self-publish. So sometimes the self-publishing, it will take about a week to get it. But, the other place will take probably, if you have Prime, they'll take, and then Prime Day is coming up. Oh, I almost forgot about that. Prime Day is coming up, not this week, but I think next week. So you might be having some discounts as well. Okay, so Dom, please reach out, message me. Okay, message me. Just go ahead and message me. I'm actually going to stop this and I'm going to check my messages so I can figure out what we're doing. Okay? All right. If there isn't any questions, Oh, get rid of the first M. Guys are cracking me up. All right. Thank you so much. 133.4. Like, this is amazing. Amazing. I love it. All right. So if you need anything, just go ahead and message me. If you have questions, do not hesitate whatsoever, because that's the only way you can get your answer. It might be an answer that you want, or it might be an answer that you weren't prepared for. But no matter what, you're going to get an answer. So, go ahead and reach out. All right. Thanks, Dom. All right. I'm going to check on that. Okay, ladies and gentlemen, I will see you tomorrow either at 1 p.m., which we're going to be working on the linear inequalities, or at 10 p.m. Oh, gosh. Yeah, I did that crazy. But here we are. But at 10 p.m., on all this is Eastern Standard Time. At 10 p.m., we're going to be working on the radicals, simplifying radicals. All right? And that's with and without variables. I'm going to try to do both. Okay. All right. Have a good night. Take care, guys. Bye now.